Hello everybody, we're the best physics team you already knows. My name is Eric Velasquez and we're having our last evidence. Here we are going to show you a pair of experiments that will blow your mind. They are amazing. Also, we're going to talk about some amazing scientists that are so intelligent, what they have done, their contributions to the media. They're amazing, they're very intelligent, not like me, but they're still going on. So, stay on.
Hello, this is Juan Manuel, and today in this video we will show you our experimental circuit. As it is required for the evidence, we decided to use a quite more complex circuit for the project and not a loud one. And there's nothing more than a distortion or fuzz pedal to things before we get into the technical stuff. One. This pedal is for music purposes, or well, at least it should be for music purposes. I cannot see any other purpose on this pedal, and its function is to make a distortion on the wave, in this case the sound wave that our instrument produces. We can also apply this effect in a lot of more things, such as our voice. It's just an effect, and even more instruments if it is required. The wave changes its form from a simple worm. Let me draw something for you. It is Our wave should look like this. But when we apply the effect, it should look like this. I have seen the wave, and yeah, it truly looks similar like this. Its form from a simple worm changes to an spiky worm, as you saw earlier. When the effect is applied, now that you know what kind of circuit it is, let me show you how the instrument should sound with the effect and without it. So, let's go. Without the effect. Now, adding the effect, it should go like this. So that's it for the instrument. Thank you. So as I showed you with my instrument earlier, let's get into the technical stuff. The voltage needed for the pedal to work is 9 volts. Actually, this is the most common voltage for the pedals in general, and 9 volts battery is enough to make it work. The current goes through the entire circuit as it should, except when the switch is off and it does not let the current work and make the distortion effect. If we get more into the circuit analogy, we can mention a couple of theories. One of them is applicable and the other is not. Let's begin with the Kirchhoff's law, that states in simple words that the current that goes in the circuit is going to be the same current leaving the circuit. In other words, the charge input at a node is equal to the charge output. Now let's move on with the one that does not apply, and I was pretty curious about this one. In our circuit we use transistors and diodes, so the Ohm's law is not applicable. Why? The Ohm's law states that the current flow through a given conductor is directly proportional to the potential difference between its ends, and the law is not applicable in the circuit because of the use of transistors and diodes, which make the current not directly proportional, as the diodes and the transistors of the circuit are semiconductor devices. The law is just not applicable in this circuit. That's why I mentioned you earlier that this is a more complex circuit, because it has got a lot more materials. And that's the thing. I can explain to you why this law, the Ohm's law, does not work in it. So with the circuit it gets a lot more easier because it is a series circuit. Sorry if you can look to my face. Well, hope you can clearly see how the entire circuit is in series. I mean, there's nothing in parallel, or at least this part looks like it's in parallel, but it is not. It is actually continuous and it is in series. So we have no problem identifying our diodes and transistors, our resistances, R1, R2. We got no problems until R9 because we're needed 9 resistances. So all good there. Our jacks, here's the entrance, and here's the input, and Here's the output of the pedal. Here's the switch, and that's it. This is for the diagram. For the parts of the circuit and the pedal itself, there were needed quite a lot of cables, two diodes, two transistors, 9 resistances, a switch, and these jacks. The input, the output, finally our potentiometer. Here it is. You can clearly see how this works. This is a beta version. It is not complete. It does not work as intended. I mean, it's quite loud when it sounds. You heard it and you saw that on the file where I show it to you how does it should sound. This is the prototype. This is that one that I made. Me and my father made. And this is a certified one. It does the same, but it's clearly better than this one. This one only has one potentiometer, and this one has four to control a lot more things, which is more complex. The switch is different, it's more like a button. And yeah, I won't open it because fixing this and seeing it from the inside, it's gonna be quite difficult. But yep, this is basically the same. But this one is even more simple because this one just controls the gain you can give to the effect. And this one controls quite a lot more things. So that's it. Thank you.
The experiment of Juan was very interesting. How the device can change the sound of his bass, it's amazing. Now, I want to show you one from my own.
Here we have our Tesla coil, a simple diagram of the circuit of a Tesla coil. And first, let's identify the elements. Okay, and this is a battery. It is of 9 volts. Then we have our switch. We have a resistor of 22 kilo ohms. Please, it is very important that when you build a circuit of Tesla coil, it has to be a resistance of 22 kilo ohms because otherwise it won't work. Okay, and the same case for this transistor. It is a 2N2222A transistor, and what this transistor will do in this circuit is work as a switch, kind of a switch, because it will create a intermittent current in the circuit, and this pulsating frequency will create a variable magnetic field along this primary coil, this little coil, and when crossing the secondary coil, this large coil will create a current with high voltage. And the more turns this larger coil has with respect to the primary coil, the more voltage it will have. And these all concepts combined with the high voltage and the high frequency in the current will create an electric field in the circuit. And this electric field will transmit wireless energy.
Thank you for explaining, Pablo. Let's keep it up. Thank you for explaining, Pablo. That Tesla's call, it's amazing. Tesla is one of my favorite scientists. And now our friends Melissa, Adrian, and Julia are going to show some other amazing scientists that have been amazing through history. Let's see them.
Now, we're going to talk about the main contributions of the most prominent physicists of the modern era, one of which is Max Planck. Max Planck had made many contributions to theoretical physics. He was a German theoretical physicist for a reason. His fame rested primarily on his role as an originator of the quantum theory, for he discovered the quantum of action, which nowadays is known as Planck's constant, h. This was discovered in the 1900s, and it revolutionized the understanding of atomic and subatomic processes. What's more, Planck was the first prominent physicist to champion Albert Einstein's special theory of relativity. It's worth to mention that the foundation of the quantum theory won the Nobel Prize for Physics in 1918.
Fermi. Fermi was the creator of the world's first nuclear reactor, the Chicago Power 1. He was being called the architect of the nuclear age and the architect of the atomic bomb. Fermi also discovered that statistical laws, nowadays known as the Fermion statics, governing the particle subject to Pauli's exclusion principle. Fermi received the Nobel Prize in Physics at the age of 37 for his demonstration of the existence of new radioactive elements produced by neutrons in radiation, and for his related discovery of nuclear reactions brought about by slow neutrons.
Heisenberg's main contributions. In 1923, received PhD in physics at the University of Munich. In 1924, received Bagnoli Legendi at the University of Munich. He published in 1925 the theory of quantum mechanics. In 1927, Heisenberg developed his revolutionary uncertainty principle. In 1932, awarded the Nobel Prize in Physics for the creation of quantum mechanics, the application of which he has inter alia to the discovery of the anthropoidal forms of hydrogen. Heisenberg was main contribution to the German atomic program during World War II in direct competition with the Manhattan Project. In 1941, he visited Niels Bohr in Copenhagen to describe nuclear research. In 1945, May to 1946, interned in Farm Hall as part of Manhattan's projects, also mission to determine German scientists' knowledge regarding the development of an atomic bomb. In 1957 onwards, Heisenberg worked on plasma physics and thermonuclear processes.
De Broglie, French physicist best known for his research on quantum theory and for predicting the wave nature of electrons. He also introduced the idea that particles, such as electrons, could be described not only as particles, but also as waves. In essence, Broglie's equation helps us understand the idea of matter having a wavelength. In 1929, he was awarded the Nobel Prize for Physics.
Another physicist that is worth to mention a lot, since all the people know him, it's Albert Einstein. Albert Einstein was a German-born physicist who developed the special and general theories of relativity. He also won the Nobel Prize for Physics in 1921 for his explanations in the photoelectric effect. Einstein is generally considered the most influential physicist of the 20th century. His research spanned from the quantum mechanics to theories about gravity and motion. Still, he is best known for his equation E is equal to mc², which states that energy and mass are the same thing, just in different forms. Albert Einstein had a massive influence on the contemporary physics. His theory of relativity shifted contemporary understanding of space completely. Along with his equation, it also foreshadowed the creation of the atomic bomb.
I hope that you have enjoyed this. We put so much effort in this, making the Tesla coil, the work from Juan, all the investigation. This is the conclusion of all our effort through this semester. Thank you for being with us. Thank you for everything. Goodbye, everybody.